Congratulations! You should be very proud of yourself. You have learned complicated linear algebra concepts, such as systems of linear equations, matrices, and determinants. You've seen them in 2x2 matrices. The general concepts are very similar, but in order to really nail them down, follow me along to see them defined in 3x3 matrices. To start, you'll be solving your first system of 3 equations with 3 unknowns, and the problem is a familiar one. You're in a similar store as before, but now your goal is to find the prices of 3 items: an apple, a banana, and a cherry. So you go to the store 3 days in a row. On the first day, you bought an apple, a banana, and a cherry and paid $10. On the second day, you bought an apple, 2 bananas, and a cherry and paid $15. And on the third day, you bought an apple, a banana, and 2 cherries and paid $12. Now the question is, how much does each fruit cost? So the way to solve this is very similar to the way to solve the previous systems with 2 equations and 2 unknowns. The first equation says that an apple, a banana, and a cherry cost $10. The second one says that the same arrangement plus an extra banana costs $15. Therefore, that extra banana must cost those extra $5. And the third one says that the same arrangement of day 1 plus an extra cherry costs $12. Therefore, that extra cherry must cost that extra $2. So banana is 5 and cherry is 2. We still need to find the price of the apple. Now look at the first equation. If the banana is 5 and the cherry is 2 and the 3 of them cost 10, then the apple must cost 3. So our solutions are: the price of an apple is 3, the price of a banana is 5, and the price of a cherry is 2. The system of equations you just solved is this one over here, system of equations 1, which has as equations a plus b plus c equals 10, a plus 2b plus c equals 15, and a plus b plus 2c equals 12. And the solution you got was a equals 3, b equals 5, and c equals 2. Now you're ready to solve more systems. Here are 3 systems to solve. Remember that just like before, some of them may not have a solution, some of them may have an infinite number of solutions. So if that's the case, please state it, even if any of the options already shows a solution to the system. And so here are the solutions. System 2 has infinitely many solutions. Why? Well, you look at equation 1, it says a plus b plus c equals 10, and from equation 2 there's an extra c and an extra 5, so that c must be equal to 5. The price of a cherry is 5. However, when you go from equation 2 to 3, there's also an extra 5 and also an extra c, so equation 3 brings nothing new to the table. When you replace c equals 5 on the first equation, you get a plus b equals 5. And actually, any triplet where the third number is 5 and the first 2 add to 5 works. So all of these are solutions to that system. That system has infinitely many solutions. Now let's look at system 3. System 3 has no solutions. Why? Well, from the first and the second equation, c is equal to 5. However, from the second and the third, c is equal to 3, because from the second equation to the third one, you bought an extra cherry and you paid an extra $3. So c is equal to 5, but c is equal to 3. That's a contradiction, so system 3 has no solution. What about system 4? Well, system 4 has infinitely many solutions. Why? Because as you can see, the second equation is 2 times the first one, and the third equation is 3 times the first one. So the first one is really the only equation here that matters. Or equivalently the second or the third, but only one of them matters. So any 3 numbers that add to 10 would work. So for example, 0, 0, 10, 2, 7, 1, 9, 1, 0, any 3 numbers that add to 10 are a solution, so we have infinitely many solutions.